So, I welcome you to the lecture series on Introduction to Cybersecurity. And today, our topic is linked libraries. And this is the basic analysis portion of our malware investigation. Well, myself, Dr. Bora. So, at the very beginning moment of this lecture, I want to show you a picture. I hope you all are aware with these technical terms you will see in this big picture. See, this is the source code file. Then compiler is going to convert it into object file. Then you'll see this is linker and different library files are linked to here through linker. Then you'll have your executable file. Okay, so this whole process is very important for you. I hope you have already got it in your compiler design class. And why I have shown this picture to you in this lecture because today we are going to talk about some libraries and they are our linked libraries. Okay. Now, one of the most useful pieces of information that we can gather about an executable is the list of the linked libraries it utilizes. Do note that the list of linked libraries is very important for any kind of malware analysis. Then code libraries can be linked either statically or at the runtime or dynamically. I hope you all know this term statics and it's dynamic time and static time. These things you know. Now, knowing how the library code is linked, it can be critical to our understanding of the malware as the information we find in the PE header can be made sense of depending on how these libraries interact and link with each other. In the last lecture, you have gone through these PE headers, and that's very important, of course. Then, as you have seen that these link libraries may be gone through statically, runtime, or dynamically. So we'll go through each of them. Now, first one is the static linking. And you know, this is the least commonly used method of linking libraries. And it is most common for our Unix and Linux. When statically linked, all the code is copied into the executable, which in turn increases the size of the file itself. Though analyzing the code thus becomes difficult as becomes extremely hard to differentiate between the statically linked code and the executable's own code. So one important advantage you'll get from the static linking that it's a kind of more secure. Okay, if static link is used, then p header file don't indicate that the file contains the link code. So this is the advantage of the static linking and mostly used in case of Unix and Linux. That's why we say that Unix and Linux are kind of more secure than our Windows. Then we have our runtime linking. It is used mainly in malware programs, especially when it's packed or obfuscated. These terms we have discussed already in our last lecture. And executables that use this technique connect to libraries only when needed. That's why the runtime linking. Okay. Windows function allow programs to call functions not listed in the program's header file. And two most commonly used library functions are the load library and get proc address. And these are very important. You should note it down. Load library and get proc address are most commonly used functions in case of runtime linking. Then loader get proc address and loader load DLL are also used. and load library and get proc address. Why we use this? Because they allow a program to access any function in any library on the system. So the functions of the load library and get proc address is that they allow a program to access any function in any library on the system. So whenever these functions are used, we can't tell exactly which functions are being linked to the suspect program. Okay, so that is runtime linking. Now we have dynamic linking, and this is the most common method used for malwares. And when libraries are dynamically linked, the host operating system searches for the necessary libraries whenever the program is loaded. And when the program calls the link library function, that function executes within the library. Okay. So the PE file header stores the information about every library that will be loaded and you know every function that will be used by the programs. Okay, so identifying the libraries being used are extremely important as it allows us to guess what the program is trying to do. Common DLLs that are mostly required and can be used to make certain deductions are these are the important DLLs. You can take a screenshot. So, first one is kernel 32 DLL. See, we have used the extension .dll. Can you tell me what this .dll stands for? So kernel 32.dll, this is a very common DLL that contains core functionality such as access and manipulation of memory files and hardware. Then we have Adobe 32.dll. This DLL provides access to advanced core Windows components such as the Service Manager and Registry. Then user32.dll, this DLL contains all the user interface components such as buttons, scroll bars, and components for controlling and responding to user actions. Then we have GDI32.dll and it contains functions for displaying and manipulating the graphics. Then we have anti-DLL.dll, and this is very important because this DLL is the interface to Windows kernel. Executables generally do not import this file directly, although it is always imported indirectly by kernel32.dll. If an executable imports this file, it means that the author intended to use functionality not normally available to Windows programs. Some tasks such as hiding functionality or manipulating process will use this interface. Okay, that is about anti-DLL.dll, very important one. Then others are like we have wchoke32.dll and we have ws2 underscore 32.dll, and they are networking DLLs and a program that accesses either of these most likely connects to a network or performs network related tasks. So they are related to our network related tasks. Then we have wininet.dll and it contains higher level of networking functions that implement protocols such as FTP, HTTP, and NTP. Okay, so these are the common DLLs. And so I hope this dynamic linking and this runtime linking and this static linking are clear to you. So we have discussed a very important part in network malware analysis, that is link libraries. So coming to today's question, and today's question is what is get proc address? Okay, and next question is what is anti-DLL.dll? So comment your answer. And these are the references I want to give credit for these lectures. I have collected most of the information from these references. Okay, so answer the questions. Okay, and stay safe at home. Meet you in the next lecture. Bye bye.